Assalamualaikum and hi. Today our group will present about the relationship between sleep duration and quality of sleep. So before we start, let me introduce you our group member. First of all is me, Muhammad Hanafi bin Muhammad Talha. The second one is Muhammad Haikal Hakimi bin Muhammad Burshidi. And the last one, Muhammad Amirul Hakimi bin Muhammad Rizwan. Let's move to the introduction. Our group chose a dataset that shows how sleep duration might affect a person's quality of sleep. The variable X represents how many hours a person sleeps and Y represents their quality of sleep. For sleep duration, the data shows that the minimum sleep duration is 5.8 hours and maximum is 8.1 hours. Quality of sleep is evaluated by rank 1 to 10, which means 1 is very bad and 10 is very good. The data shows that the quality of sleep is ranked between 4 to 9. For this case, we will use the least square method to study the relationship between sleep and stress. We will apply this method to the three different models that are linear model, quadratic model, and cubic model. We will calculate the least square approximation for each model and compare the results to see which one fits the data best. The best model will be chosen based on how close the predicted values are to the actual stress level. First of all is linear model. The equation for linear line is y equals to a plus bx, and then we substitute the point into the equation. After that, we write it in matrix form, which is mv equals to y. For m, the first column is constant and the second column is value of x. After that, we write it in normal equation for matrices, which is m transpose m times v equals to m transpose y. After that, we need to find the least square solution using the formula V equals to inverse of m transpose m times m transpose times y. And we can get the y equals to negative 6.0313 plus 0.94011. And then we can get the best fit linear curve. Next is error vector. We find the error vector using formula E equals to y minus mv, and the last one is magnitude error. Magnitude error equals to 3.722.
Okay, now we will move to the next model, which is his quadratic model. So for the quadratic line is y equals to a plus bx plus cx squared. So we substitute the point into the equation. Next, we move on. For the metric form is mv equals to y, and the next one is normal equation for matrices. So m transpose m equals to m transpose y. So now let's move on to the least square solution. V equals to m transpose m inverse and m transpose y. So y is equals to x 1.977580655 plus 0.182770646933175 times x squared. And here we got the best fits quadratic curve. And next, we will move on to the error vector. So for the magnitude error, we got 1.25381325 38072153
For the cubic model, the equation of cubic line is y equals to a plus b multiplied with x plus c multiplied with x squared plus d multiplied with x cubed. With that formula, we substitute the point into the equation. After that, we substitute the value into the matrix form, which is mv equals to y. For the first column is the constant value. For the second column is the x value. For the third column is the x square value. and the fourth column is the x-cubed value. After that, we find the normal equation for matrix. The formula is M transpose M multiplied with V equals to M transpose Y. After that, we got the value of A, which is equal to 181.0, the value of C, which is 1153.1, the value of C, which is equal to 8371.01, and then the value of D, which is equal to 61531.4390. Next, for the least square solution, the formula of least square solution is V equals to inverse M transpose M multiplied with M transpose Y. And then we find the value. After that, we substitute the value into the formula, which is Y equals to negative 191.8675 plus 84.7230 x minus 12.2493 x square plus 0.5985. For the error vector, the formula is error equals to y minus mv. After that, we magnitude the error value to find the magnitude error, which is equals to 1.4459. The analysis and conclusion from the three model, the following error magnitude in the approximation are obtained as shown below. For the linear model, we got 3.7220. For the quadratic model, we got 1.2538, and for the cubic model, we got 1.4460. The best fit curve is in this case, which will give the best approximation, is the quadratic model because it has maximum error in terms of its magnitude.